Hello students, welcome to my YouTube channel. In this video lecture, I'm going to answer questions from 41 to 50. I hope you have been watching all my lectures so far and you are finding it easy to answer questions related to 1 in 60 rule and especially the descent questions. Let's continue that streak and start with question 41. What will be the rate of descent when flying down a 12% glide slope at a speed of 175 knots? So, glide slope is equal to tan theta into 100. So substitute the values. 12% slope will be equal to tan theta into 100. So tan theta will be equal to 12 divided by 100, which is equal to 0.12. So theta will be equal to tan inverse 0.12. Tan inverse 0.12 equates to a value of 6.8 degree. Now, use the ground's rate of descent formula. Rate of descent equals to glide slope angle multiplied by speed divided by 60. So glide slope angle is 6.8 degrees. Ground speed of your aircraft is 175 knots. Okay. Multiplied by 101.3 feet per minute divided by 60. So 6.8 into 175 into 101.3 divided by 60 is 2009. So the rate of descent is 2009 feet per minute. Next, at 100 miles from a VOR, aircraft commences a descent from flight level 330 in order to arrive overhead VOR at flight level 100. What rate ground speed is 240 knots? What is the rate of descent? So let's say this is your aircraft. This is your VOR station. Okay. Now you are at a distance of 100 nautical miles from this VOR station. Okay. Aircraft is at 33,000 feet. The VOR station is at 10,000 feet. The speed of your aircraft is 240 knots. The time will be equal to distance divided by speed. So 100 miles divided by 240, that is equal to 0.41 or 25 minutes. So what will be the rate of descent? Rate of descent equals to change in height divided by the time taken. So 33,000 minus 10,000 is 23,000. Divided by time is 25 minutes. So 23,000 divided by 25 is 920. So rate of descent is 920 feet per minute. Next. 43. Aircraft is on an analyzed 3-degree glide slope which passes over the runway threshold at a height of 50 feet. That means the glide slope passes over the threshold of the runway at a height of 50 feet. Okay, so how will you represent it? Draw a runway. There is a glide slope which passes over the runway at a height of 50 feet. So height is 50 feet over the threshold of the runway. Okay, that means this glide slope ends up, okay, or this glide slope ends at the touchdown zone of the runway, at any portion of the runway which is ahead of the threshold. Okay, DME is 25 miles. What is the height above the runway threshold elevation? Above the runway threshold elevation. So 25 nautical miles. So we will have To draw one triangle, its base will be 50 feet above the threshold of the runway. Okay, so this triangle is with respect to the glide path. So the height of your aircraft will be first determined from above the glides, from above 50 feet of the threshold. Okay, so this value will be x, height of aircraft above the threshold of the runway, above 50 feet threshold of the runway. Okay, we are told to find the entire height, that is x plus this extra amount 50 with respect to the threshold. So let's find the x value. The glide slope is 3 degrees. Glide slope is 3 degrees. Okay, so you will use 1 in 60 rule. Here they have specified or instructed us to use 1 in 60 rule formula. Okay, so 1 in 60 rule says track error angle equals to distance off track divided by distance gone into 60. So 3 degree equals to distance off track, we have to find out x, distance gone 25 miles into 60. So x equals to 25 miles, convert that into feet, so multiply by 6080 into 3 divided by 60. 25 into 6080 into 3 divided by 60. 7,600 feet. So that means this aircraft is 7,600 feet above the 50 feet threshold of the runway. So, okay, so 7,600 feet from the base of this glide slope. We have been told or asked to find the total height of aircraft with respect to the ground surface. So that total height will be equal to 7,600 plus 50, that is 7,650 feet. Okay, so what is the height above the runway threshold elevation? So threshold is on the ground surface. So this height plus this 50 feet height. What will be the rate of descent when flying 5% glide slope? So glide slope in terms of percentage equals to tan theta multiplied by 100. So 5% glide slope equals to tan theta into 100. So tan theta equals to 5 divided by 100, that is 0.05. So theta of glide angle equals to tan inverse 0.05. So tan inverse 0.05 is 2.8 degrees. Rate of descent equals to glide angle into speed into 101.3 feet per minute divided by 60. So 2.8 degree into 540 knots into 101.3 divided by 60. So 2.8 into 540 into 101.3 divided by 60 is 2552.7. So 2553 feet per minute. Okay, this is your rate of descent. Aircraft is at a height of 2,500 feet on a 3 degree ILS glide path. What will be the distance? Okay, so this is your aircraft on the glide path. This is the horizontal distance. So aircraft is at a height of 2,500 feet, 3 degree glide slope. We have to find this horizontal distance. So use 1 in 60 rule formula, angle equals to distance off track 2,500 feet divided by distance traveled unknown multiplied by 60. So 2,500 into 60 divided by 3. So 2,500 into 60 divided by 3 is 50,000 feet. In terms of nautical mile, convert 60 divide by 6080. So it is 8.2 nautical miles. Let's use tan theta formula. So tan of 3 degree equals to opposite 2500 feet divided by distance traveled. So distance traveled will be 2500 divided by tan 3. 2500 divided by tan 3 is 47703 feet, or 6080 division 7.8 nautical miles. So approximately 8 nautical miles. Either way. Okay, either method will give you that approximate value of 8 miles. What will be the rate of descent when flying 6% glide slope at a speed of 500 knots? So again, same formula, slope equals to tan theta into 100. So 6% equals to tan theta into 100. So tan theta equals to 6 divided by 100, 0.06. Theta equals to tan inverse 0.06. Is 3.4 degrees. Next, rate of descent equals to glide slope angle into speed into 101.3 divided by 60. So 3.4 degree, speed of 500 knots into 101.3 divided by 60. So 3.4, 500 into 101.3 divided by 60. So 2870 feet per minute. Okay, next. At 4 o'clock 30 minutes, aircraft is in straight and level flight 185 nautical miles from a VOR station. It's required to descend at a rate of descent 1800 feet per minute to be at flight level 80. So, so aircraft is at flight level 370. Okay, so this is your VOR station. This is your aircraft. Now you will travel straight and level flight for some time, and then you will reach your top of descent, from where you will start your descent towards this VOR station, Okay, so now at the time at this place is 4 o'clock 30 minutes. Okay, and so ground speed in cruise is 350 knots. Okay, cruise speed is 350 knots. Aircraft is at flight level 370. It has to overfly the VOR station at flight level 80. The descent ground speed is 232 knots. The ground speed of the aircraft during descent is 232 knots. Rate of descent is 1800 feet per minute. And aircraft is at a total distance of 185 nautical miles from this VOR station, right? So we have to find the latest time, the time at which aircraft will start its descent. That means we will have to calculate first the time aircraft will travel, how long the aircraft will travel, straight and level at flight level 370 from 4 o'clock 30 minutes to this point of descent. Okay. So first things first, step by step we will go. Now speed of descent is given, rate of descent is given. These two things are given. Now, what is the rate of descent formula? Rate of descent equals to change in height divided by time taken to change that height. So 1800 equals to 37,000 minus 8,000, that is 29 29,000 feet, divided by time taken to make that change. Cross multiply will give you 29,000 by 1800. So 29,000 divided by 1800 is 16 minutes. So you will require 16 minutes to descend from 37,000 feet or 37,000 feet to 8,000 feet. Okay. Now, with this time of 16 minutes, with this speed of 232 knots, you will cover a particular horizontal distance. You will cover a particular horizontal. You will cover a particular horizontal distance towards the VOR station. So let's calculate that distance. That distance will be equal to speed into time. So 232 knots into time 16 minutes divided by 60 will give you a horizontal distance of 232 into 16 divided by 60, 61.8 or approximately 62 nautical miles. So in descent, you are going to cover a horizontal distance of 62 miles. Total horizontal distance is 185. Out of that 185, you are going to travel 62 miles in your descent. So what will be the remaining horizontal distance? 185 minus 62, that is 123. 123. Correct? Now this is the distance you will have to travel straight and level. Okay, and after covering that distance, you will begin your descent. So if you know the distance value, you have the distance value, you have the speed value, you can calculate time. So time taken will be equal to distance by speed 123 by 350 is equal to 21 minutes. So you will take or you will require 21 minutes to travel from this point to the point of or to the point of descent or top of descent. So 4 hours 30 minutes plus 21 minutes equals to 4 hours 51 minutes. So that means you will begin your descent at 4 hours 51 minutes. 65 miles you are away from VOR. You have to descend from 33,000 to 10,000 at a speed of 340 knots. What is rate of descent? So rate of descent equals to change in height divided by time. So change in height 33,000 minus 10,000 is 23,000. Time equals to distance by speed. Distance is 65, speed is 340, so 11 minutes is equal to 2090.9 or 2091. So the rate of descent is 2090 feet per minute. Next, at 70 miles, 75 miles from a VOR, you descend from 35,000 to 12,000. At a speed of 250 knots, what should be your rate of descent? So this is your VOR station. This is your aircraft. 35,000 से लेके 12,000. So 35,000 to 12,000. Rate of this, okay, 75 miles away. Speed 250. Now, the time taken will be equal to distance divided by speed, so 75 miles divided by 250 will be equal to 18 minutes. Okay. Now, rate of descent equals to change in height divided by the time taken. So 35,000 minus 12,000 is 23,000 divided by 18 minutes is 1277. Okay, or approximately 1280 feet per minute. That will be your rate of descent. 50. Last. Aircraft is on an ILS 3-degree glide path which passes over the threshold at 50 feet. You are 25 miles away from the threshold. What is the height above the threshold? Okay, similar to one of the previous questions. Use 1 in 60 rule. So let's draw this. This is your runway, threshold. Your aircraft is on a 3-degree glide path. Let's join this. This glide path is 50 feet above the threshold. 50. Okay. So this is triangle. Now we have to find out this x value. Height of aircraft from above 50 feet of the threshold of the runway. From 50 feet above the threshold of the runway. Okay. 3 degrees. Now 1 in 60 rule. Angle 3 degree equals to distance off track. Distance off track is x. Distance traveled or horizontal distance is you are 25 miles away. So 25 into 60. So 25 into 3 divided by 60, that is 1.25 nautical miles. 1.25 into 6080 is 7,600 feet. So this x is 7,600 feet. So height of aircraft from the ground surface is 7,600 plus this extra 50, that is 7,650. Okay. So the final height of aircraft above the runway threshold elevation is 7,650. So select that value which is closest to this value. This brings the curtains down on this lecture. I hope you have understood, enjoyed, and learned something new today. Thank you for your time. All the best. Keep practicing these questions again and again till you gain proficiency and confidence. Do let me know your feedback, your questions in the comment box. In my next video lecture, I will solve the next 10 questions. So I'll see you there.